Great job kicking off Wi-Fi Check 2018. I'm very excited to be here and to see all of you here. Okay, I don't know. This is my second Wi-Fi Trek. I was actually at Wi-Fi Check 3 in New Orleans, and I was just in the audience at that time. This is my first time speaking here. And my presentation today is on Wi-Fi performance mental model. But before I get into the mental model, I would like to take us back to 2005. I know Tom took us back to 1997, but in 1997, I was an undergrad in computer science. So I'm only going to take us back to 2005. Back in 2005, Wi-Fi was pretty simple back then. 802.11b was the latest and greatest. 5 gigahertz was mostly used for public safety radios and weather radar. 2.4 gigahertz was more likely to be used by cordless phones, baby monitors, and even microwaves than it was to be actually used by Wi-Fi. At the time, I was working on wireless mice and keyboards, and actually this little Logitech clicker was one of our customers. I did the wireless in here for the clicker, so hopefully it works today. And I spent my nights and weekends working on a port mount spectrum analyzer that I named Wi-Spy. Now back then, being able to look at the spectrum was actually pretty important for Wi-Fi because all of that non-Wi-Fi stuff was going to have a big impact on the Wi-Fi. And if you actually had a Wi-Fi connection, because it was only 802.11b and it was pretty simple, it most likely worked. So Wi-Spy became pretty popular. I started a company, and we kind of took off from there. Now, as Wi-Fi gained popularity and Wi-Fi started impacting other Wi-Fi networks around it, we created inSSIDer. And inSSIDer's on the left over here. The little view of the networks and signal strength and channel overlap, that's pretty common now, but back then this was the first tool that showed that. And we wanted to show how the networks impacted each other and how they overlapped. And looking at this view, you can also see why 1.6.11 is so important and how channels 2 and 3 overlap and cause a lot of problems. Also started diving into Wi-Fi a little bit more and packets, and started using Wireshark and realized that Wireshark is really kind of tedious and cumbersome to get an overview of what's going on in the Wi-Fi. So we wanted a better way to visualize the high level what's going on in Wi-Fi, and we developed Eye P.A. After that, we just kind of continued to iterate and polish our tools. Got to about 2015. And we had 10 years working on Wi-Spy and Channelizer, 8 years on inSSIDer, and 3 or 4 years on Eye P.A. And so our tools are becoming pretty polished and mature at that time. Also, in there, after we developed Eye P.A, we realized how little we knew about the packets that were going in the air. We spent a lot of time in the spectrum, but when it got to the packets, we're like, oh, wow, there's a lot of stuff here. And so we brought in Keith and Robert to train us and get us all CWNP certified. So we had Robert come in, took a week off of the entire company, and basically got everybody CWNA certified. I probably have one of my claims to fame is I'm probably the only person here whose mother has a CWNP certification. Anybody else can claim that? Yes. My mom worked for me at the time, and she has a CWTS, which she is proud to say is a lifetime certificate. So she is still CWTS. Anyway, so we spent years kind of polishing our tools and making them all great. And at the time, also had 2 little kids, a 1-year-old and a 4-year-old. So my life kind of became more focused on the family, and MetaGeek kind of went into cruise control. We didn't really do much on innovation for a couple of years in there. And that got us to about 2017. And I started to ponder, OK, you know, we've been doing this Wi-Fi thing for a while. What's next? Do we branch out beyond Wi-Fi, or do we keep doing Wi-Fi? If we do Wi-Fi, what are the problems that we should solve? Should we work on mobile tools? You know, iOS and Android are very popular, but they're not as powerful as you can do on a desktop. So is that going to work for us? You know, can we make tools for mobile? Sidekick came out in 2017 that Tom mentioned, and we had a lot of requests for a higher resolution Wi-Spy. And I thought about it, and we looked at it, but I was like, OK, yeah, I can get higher resolution, but what problems are we trying to solve with that higher resolution? And I was kind of struggling with where MetaGeek should go and what we should do next. About this time, I got a call from Janice at Riverbed, and she calls me up. She's like, hey, Ryan, you guys have been reselling your PCAP NX for years. It's the best Wi-Fi packet capture on Windows. But as you know, we just OEM that device from a manufacturer in Asia. They stopped making it a couple years ago, and so we bought a big supply. Well, our supply is now running out. And if you want any more Air PCAP, you need to order them today. And I kind of went, oh, crap. We have a Wi-Fi packet analysis tool on Windows, and we have no way to get the packets in. So we ordered as many as we could, which gave us a 6-month supply of Air P.A. And then we had to figure out how are we going to keep Eye as a product if we can't get packets. So how do we get packets? Luckily, as Tom mentioned earlier, the Wi-Fi community is great. Everybody's friends. We're friends with the other Wi-Fi vendors. And so we worked agreements with TartLogic and Tamasoft to get some of their packet capture technology to be able to integrate into Eye. And then Vanessa and I spent 6 months, the first half of this year, working on Eye. Vanessa's back in the corner. Raise your hand, Vanessa. She's my partner in crime on getting off-the-shelf Wi-Fi adapters to work in Eye. So we spent the first half of 2018 deep in the guts of Eye and looking at packets in every bit in the packet, what the radio tap headers look like, what the PCAP headers look like, and trying to figure out and make sure everything's integrated properly. And while we're in the middle of all of that, the Wi-Fi stopped working at MetaGeek. I shouldn't say it stopped working. The Wi-Fi was working, but everything had been really smooth. And then one day, somebody can't get an IP address. The Wi-Fi kind of works, but you're not getting online and doing anything. By the end of the week, about half the company randomly wouldn't be able to get an IP address. You guys are probably familiar with situations like this. But this was our first big Wi-Fi issue at MetaGeek. Our IT person, being MetaGeek, he fires up Channelizer. And the spectrum is fine. There's nothing wrong with the spectrum. So he fires up Eye. Maybe it's a packet issue. Well, Eye is fine. You're getting a connection, you're getting association, you're just not getting an IP address. So dug into the switches and the DHCP and the server logs and everything. And after a couple of weeks, talked to AeroHive support. And the helpful AeroHive support person said, hey, there's this like high density setting that you might want to turn on. Sometimes it fixes weird problems like this. And lo and behold, we turned it on and everything is fine. So I kind of stepped back and went, wow. OK, we're a Wi-Fi tools company. And our Wi-Fi tools were completely useless in this situation. Oh my gosh, OK, here's something I need to work on. Our tools should be more relevant and be able to help in situations like this. A situation where 1 week we're, I guess, low density, and the next week we're high density and things don't work anymore. But none of the tools were showing us that transition and how we got to that point. So now I have a reason to move forward with MetaGeek and what we should do. And at the time, I also updated our mission. Our new mission is to dramatically increase the confidence and ability in maintaining a secure performant network. And with that, for the confidence and ability in a secure performant network, I needed a way to measure performance. I needed a way to say, hey, how are we doing on this mission? How do we assess whether our tools are actually measuring performance and improving performance of Wi-Fi networks? So I put together a little mental model, a kind of framework for how do we measure this. And being the geek that I am, my mental model is a math equation. So it's a simple math equation that basically says the performance equals capabilities minus the environment. And the capabilities that we're talking about are mostly in the hardware. You're talking the number of channel spatial streams that you have, your channel width, what's your antenna sensitivity. There's a few things in your access point settings like what channel widths are you supporting, what basic rates do you have, things like that. So these are the capabilities in your device that basically give you the theoretical maximum performance that you can achieve. Now, as we all know, capabilities differ wildly in different clients. I actually have an iPhone 5S. I love this thing. It's nice and small. It fits in my hand. It fits in my pocket. It's a great phone, except for the Wi-Fi is only 802.11n. It's kind of crappy. So I know someday soon I'm probably going to upgrade my phone, but I don't really want a big one. So I'm sticking with the small for now. But I should probably switch to an iPhone 6 or 7 at least, or maybe the XS Max, Uber Goober, whatever it is, that has 2 or 3 spatial streams. Mike Albano put together a greght website. It's basically just a giant Google sheet of different clients, and it shows all the different client capabilities. It shows what channels they support, PHY types, spatial streams, a lot of different things like that. And bonus, there's a PCAP file that you can download for most of the clients that has a sample probe request. As you know, the probe request, probe response are how the two sides exchange their capabilities so they can understand the intersection of their capabilities. And it's this intersection of the AP and client capabilities that give you the theoretical maximum performance of that connection. So if we look at what this means in real life, this is my iPhone 5S that I talked about, and my HP laptop. I know a lot of you guys are big Mac fans, but that HP is actually pretty nice. It's small, it's thin, It's powerful, it has a touch screen, and I can flip it into tablet mode. So that's my laptop right now. And we have the AeroHive AP230s with the 80 megahertz channels disabled. So we have 20 and 40 megahertz available, which gets me to the iPhone 5. I can get 150 megabit per second data rates. On my laptop, I can get 400 megabit per second. OK. Now that we talked about the capabilities, we know that that maximum theoretical theory doesn't actually last very long in the real world. And all that real world stuff is the Wi-Fi environment. It's everything between the antennas of the two devices that impacts what we can actually accomplish in our connection. So we have non-Wi-Fi interference, which is becoming, I think, less of an issue than it used to be, but it's still there. We have other Wi-Fi. We have airtime that's getting taken up. We have just plain distance between the two devices and walls, all those sorts of things. So that's the Wi-Fi environment that's impacting us. So we can't actually achieve the theoretical maximum a lot of the times. And this chart kind of shows how some of these different things integrate together. It's kind of small, sorry. This is showing spatial streams, data rates, and signal strength. So on the y-axis, we have data rates. And the x-axis, we have from really crappy signal strength to really great signal strength. And this shows 3 spatial streams with 3 being the top, and then 2, and then 1. And so you can kind of see, as your signal strength increases, your data rate will increase. And the more spatial streams you have, the higher your data rate will be for that signal strength. If we put some actual clients on here, we can see how different clients interact and how all of these things impact the different clients. So this is in our office. It's showing my iPhone 5S. It's showing Vanessa's MacBook Pro, and then Adam's iPhone 6. Adam kind of sits next to us. So I'm about 15 feet away from the access point, pretty close. There's one wall between the access point and me. Vanessa's office is a couple doors down, and so there's a couple more walls in the way. And then Adam kind of sits in the hallway and has more line of sight to the access point. So in this situation, my iPhone 5 and Vanessa's MacBook show the same signal strength, even though she's 2 doors down and there's a couple more walls in the way. I think it's just because the antennas smashed into this iPhone 5 aren't great compared to the antennas in the new MacBook Pros. So her laptop can get a lot better signal strength than my iPhone can, even though she's farther away. Another interesting thing is that Adam's iPhone, even though it only has 2 spatial streams, is getting the same data rate as Vanessa's laptop with 3 spatial streams because he's got a better signal strength. Now, what would happen if the AP only had 1 spatial stream? We kind of collapse it all down to the 1 spatial stream line, and now Vanessa's laptop gets the same data rate as my iPhone because we have the same signal strength. Adam's phone that gets a little bit higher signal strength gets a little bit better data rate, but not great because it's only 1 spatial stream. Now, let's look at the performance part of this, now that we've talked about the capabilities and the environment. The best way to measure performance is typically throughput. If you're doing a lot of local communication, so you're not going out to the internet, then doing a local iPerf server would be a great way to measure throughput. Since most of what we do at MetaGeek is going out to the cloud, going out to Google Drive and our other servers like that, then I just did a fast.com speed test. And if you look at these 2 tests, you notice that the iPhone does indeed perform not as good as the laptop. The laptop is a little bit better. Theoretically, the laptop should have been a lot better, but you run into all those bottlenecks going out into the actual internet. So it was about 20% better in this instance. This is really tiny, sorry. This is showing Eye P.A, the packet analysis from that speed test on the phone. And it shows us that the data packets are indeed sent at the theoretical maximum of 150 megabits per second. And if you guys can't read that small print, just believe me, it says 150. The laptop gets the theoretical max of 400 megabits per second, as expected. I'm only 15 feet away from the access point, so it's really close, and the Wi-Fi environment isn't impacting it too much. So I said, OK, let's go way down the hall and get more of an impact from the signal strength. So I went way down the hall, and the phone drops down to about 120 megabits per second, and the laptop drops down to 130 to 270. I did a speed test at this point, too, and the laptop ended up a little bit faster than the iPhone, but not too much at this point. So that's kind of how the Wi-Fi environment impacts the capabilities, and we don't actually achieve our theoretical maximum. Now that we have this math equation of performance equals capabilities minus environment, we can start using it to assess different situations. We can say, if a user comes up to you and says, man, the Wi-Fi sucks here, you can be like, well, yeah, you have an iPhone 5, you really should upgrade to a new iPhone. or it could be something in your environment. There could be other interference. There could be other signals going on. There could be a lot of airtime taken up by other networks, so there's just no airtime for you to use. And then you can start saying, which of these things, the environment or capabilities, is easier or cheaper for me to improve? OK. Going back to the MetaGeek mission of improving confidence and ability in a secure performant network, let's look at the confidence side. And I think the confidence is highly correlated to the probability that the performance is greater than the needs of your network. Now, network needs vary wildly. Just think back to the last time that Apple released an update to Mac OS. And all of a sudden, boom, all of your clients are going to download a 1 gigabyte update. Now, your network needs are just shot through the roof. Or if you do residential, the next season of Game of Thrones comes out, and boom, everybody's streaming 4K video. And so the network needs vary wildly. The performance of the network can vary wildly. And I think this is why the confidence that we have, or the users have in the Wi-Fi, tends to be pretty low. But if we have ways to show the historical trends of performance and needs, now we can become much more confident in the future of future performance of our network. So putting some of this together, and as the chief geek of MetaGeek, I'm like, what do our tools need to do? And I believe that the next generation of Wi-Fi tools needs to be able to show the AP capabilities, the client capabilities, the intersection of these capabilities, and show what the theoretical maximum performance of that connection could be. And then also show what the environmental impact on the connection is. If I'm not getting my maximum data rates, why not? What's going on? Is it signal strength? Is it RSSI? Is it something else that's impeding the performance? If I'm not getting, if the airtime is getting taken up by other networks, I need to be able to see that. I need to see all of the impact of the environment. And I also need to be able to see the historical context of what's going on in the network. Is the network getting busier? Are my clients, are they getting more clients? Are the clients using more airtime? Are other networks using more airtime? What's going on in this environment over time? If everything worked great last week, but this week I have a problem, what's changed? These are the types of things that would really help us solve Wi-Fi and help it to perform better. So these are the things that we're working on at MetaGeek, and that will go into our next generation of tools. And if you guys are have any questions or are curious about what those tools look like, have any comments on the mental model, we have a booth over in the corner. And I'd like to say thank you all for the opportunity to present to you today and to share my thoughts with you. And I hope that you enjoyed the rest of the Wi-Fi Check 2018 conference. Thank you.